Okay, bro. So this is part three of the lecture. So yeah. So right here. So it would be let's start off with like the question. So the questions on the side, but this is the basic knowledge that he told us first. So here you go. So either like the Mendel's genetics thing. So it would be A, right? And that way you go to A, right? And three. Okay. So right here, homozygous normal. I don't know why he put two recessive alleles. Is usually homozygous normal would be AA. You would assume it would be AA, but in this question, he just said homozygous normal would be AA, right? And heterozygous mutant, so a mutant, not normal. Heterozygous mutant would be AA and AA, right? And homozygous mutant would be capital A and capital A, for this question. Yeah. So the question is asking, um, if heterozygous and homozygous mutant develop the Huntington's disease, what's the probability that the child is a homozygous mutant given that they have the disease, right? So first we start off like just giving variables to these based off the formula that I showed in the previous parts. So don't worry, I'll show you it. This disease would be D, and homozygous would be HOM. Homozygous mutant would be HOM. It's just variables, right? And the formula you can apply would be A. You remember this one that I showed you in the previous parts? You probably remember. And this would be probability A given B, right? And P, this would be HOM D. So D would be the past, D would be the past, and HOM would be the present, right? And yeah, that's I don't know why I read equals sign, my bad. And so let's start off with the branch. By the way, he shows the branch example. There's probably different ways to do it, but he just showed this. So yeah, so whatever. Here we start off with disease, or you don't get disease. Prime means no disease, okay? So D prime is no disease. Wait, he drew it like that. So I'm at D prime up top and disease on the bottom. I'm so sorry. All right. So yeah, P in this case with disease would be 1/4 because without disease, there's only, if you look at the Mendel genetics, only one of them is normal. So without disease, right? So it'll be 1/4, and this will indicate as AA, right? Because only one of them is. And the disease would be 3/4. Like the 3/4 will be included like AA, which is a homozygous mutant, AA, which is heterozygous mutant, and this AA, which is also heterozygous mutant, right? So that would be 3/4 of them. And so now we gotta narrow our knowledge. Basically, we gotta narrow it. So first was D and D prime, and then it was regular D, right? And then now, after D prime, we would be actually no. Let's start with the disease because it's more easier to like explain it. So with disease, if you have the disease, HOM. Remember the formula that we did before. So HOM, or homozygous mutant, or was it homozygous mutant? Yeah, homozygous mutant, or not a homozygous mutant. So remember, there's only three of the values, right, that we get. So the denominator we know because there's only three of them will be 3, and homozygous mutant. So homozygous mutant, we only have one of them, right? So it'll be 1/3. And homozygous mutant that is not something that is not homozygous mutant, we have two of them because we have two heterozygous mutants. So that would be 2/3. So this one would be the homozygous mutant would be AA, and this one would be the AA and the AA, right? And if you want to write like this in terms of the formula, this was the present because we're working on the present right now, right? And this would be the past, which was the D. The D was a past, right? And yeah, that's pretty much it for the disease part. I mean, like the disease part. So now let's go on top, which was non-disease, right? So give me a second. Let me just get an eraser. It's a little like. Yeah. So this is Yeah. There we go. What's next? So. My bad. I forgot to write the prime. Yeah, D prime, which is not disease. So for not disease, there's only A. We already know that, right? And again, there's also two outcomes of them. So either we write the formula this time because we don't have the thing. So we write the formula in this way. So it would be P AA prime, which is not AA. It will not accord with AA, or it would accord with AA. If you get it, right? So when oh my god, I forgot the prime, sorry. And this would be equal to 1 over 1. So just remember, a quick trick, we always take the numerator and put on the denominator and after the tree branch. So in this case, it would be 1, right? The denominator would be 1. And how much AAs do we have in the denominator? We have 1, right? So it would be 1 over 1. And for the top part right here, not an AA, so the denominator would still be 1. But what would be the numerator? So we don't have AA, so and AA was the only option, so it would be 0 over 1. Get it? So it would be 1, 1, 0, 1, and that's it. And yeah, that's pretty much it. That's all he explained for that question. So yeah.